to extend warm and hearty welcome to all of you present here. Distinguished chief guests, on and off the dais, my dear engineers, students, faculty and staff. The Engineers Day celebration has provided us with a forum where we extend our sincere appreciation to the work of all the engineers in the world who have played a vital role in shaping our society. Today in the morning session, we had some thoughtful insights on space exploration, Industry 5.0, Industry 4.0 and technology advancements from our beloved chief guest, Sri A. Rajan sir, and through the panel discussion we had from the eminent chief guests and the esteemed experts. Life has been made considerably easier, to be very frank, and more convenient with technology. To be very frank, to prepare a speech or a welcome speech or a vote of thanks, we normally used to take 40 to 50 minutes earlier. Now it takes 5 minutes, or 10 minutes. Thanks to all the wonderful engineers who have worked behind the development of the smart AI tools. I believe you all agree to this. Similarly, life has been made much easy by the sincere efforts of all the engineers worldwide. I would request everyone to give a big appreciation to all the engineers. Not all the engineers also. Just don't feel like I am not an engineer. It's not for me. See, it's a network. Okay, if somebody has to function, they have to be, as in the morning, Siddharth was mentioning regarding the chess maestro, the India has produced recently. So it's a network where everybody has to help each other, everybody has to support each other. So engineers are just because there is a big support from the entire society. So on this Engineers Day, I would like to again appreciate all the engineers, and I am sure that we all are eagerly waiting for the keynote address by the esteemed guest today. Without any further delay, I would like to move to my duty assigned today. I would like to welcome the guest of honor, Mr. Karthik Parshuram, Director at Kerala Startup Vision. Welcome, sir. Welcome, sir. Our sincere welcome to Mr. Pradeep Kumar P, Operations Director Chandrayaan 3. Welcome, sir. I would also like to welcome Mr. Sridhar Vembu, Founder and CEO Soho Corporation, who will be joining us online for the keynote address today. Sincere welcome to Mr. Sunil Haridas, Core Member BTF Kerala. My sincere welcome to Sri Surendra Kumar, Core Member BTF. Once again, I extend heartfelt welcome to all the esteemed guests, participants from various colleges, SEMS management, BTF core members, group directors, HODs, principals, engineers, especially students, staff to this valedictory function. And I hope that today's celebration of Engineers Day serves as a reminder of remarkable contributions by the engineers to our society. Thank you.
Thank you, sir. Now, for the keynote speech, I invite Mr. Pradeep Kumar P, who is the Operations Director of Chandrayaan 3. Pradeep Kumar P is a highly accomplished professional with an extensive career at ISRO. Sorry, there's a change. Now, for addressing, I invite Mr. Karthik Parashuram, who serves as a director at KSUM, where he manages critical functions such as incubation, investments, funding, and Fab Labs. Boasting 14 years of industry experience, he has an impressive track record with prominent organizations like Honeywell and NTPC. During his tenure at Honeywell, Karthik spearheaded the services and digitalization business for a multi-million dollar product line. Prior to this, he held a senior managerial position at NTPC. Karthik holds a degree in instrumentation engineering from NSS College of Engineering, Palakkad, and has earned an MBA from esteemed IEM Ahmedabad. With his extensive experience and top-tier education, Karthik Parashuram plays a pivotal role in driving innovation and operational excellence. Sir, please.
Thank you, and I must first of all, offer my sincere apologies for being unable to make it in the morning due to, a rather emergency meeting that I had to attend. So, thank you for the opportunity, and let me begin, by offering my congratulations as well as my pranams to, the dignitaries from ISRO, especially, Director Sir, Dr. Rajarajan, and Pradeep Sir, and all the other people who have been, at the helm of, bringing our country greater laurels day in and day out. So, I mean, I bow before you, sir, and thanks for gracing this occasion. And really proud to be, being a participant with you on this program. So, in the interest of time, so I would just like to, put in a few words, or rather I would say food for thought, as people call it. So, I mean, these days, it's a common, trope that, startups are changing the world. The startup is like the cool thing to do out of college. Just about everybody is asking somebody to, become an entrepreneur. But, I mean, have you ever thought, why is it that, startups have become so interesting and startups have become, such a buzzword of our times? So the fundamental reason is that, and I'm sure the esteemed guest from ISRO will agree to this. Historically, when our country was being built, problem solving as such, was something that was done either by the large public sector undertakings, like Indian Oil or ONGC or ISRO, SAIL. A lot of huge behemoths in the public sector were built. And they were the ones who were spearheading, efficient problem solving, right? But as our country grew and as more and more access to technology gets enabled, more and more access to capital becomes available. Technology is a great enabler and a leveler, right? So when you have access to technology and capital, and with the large talent pool that we have in our country, and especially amongst the likes of you, problem solving at scale as an activity gradually gets shifted from the PSUs or the government into the private sector and into micro enterprises that we like to call startups. So that is how the world is changing, and what is enabling that change, as rightly pointed out by the previous speaker, is actually the development, deployment, and the access to technology. So that is what is really shaping the world, and you really have a chance, to be part of that revolution, to be part of that change, right? So my urge or my request to you would be to open your eyes and ears and be attentive to the world around you. Spot problem statement. See whatever you're learning can be applied to solve that problem efficiently. If it is a problem that has already been solved, you don't have to break your head on it. Instead, ride sharing is not a problem that needs to be solved anymore. But there are other problems that need to be solved. And these days, the ISRO dignitaries will agree, the sheer number of startups that they are working with day in and day out is tremendous. 10 or 15 years back, if someone said that they are going to develop a satellite or they are going to launch a rocket, people would have just laughed out, right? But these days you have companies like Agnikul Cosmos who are actually trying to develop launch vehicles, and it's a great team that is behind it. So the world is indeed changing. It is not a fairy tale anymore when you just go out and say that I want to develop a satellite and I want to launch. Just yesterday, we have managed to support a company that is actually trying to develop a nano satellite. So we approved some investments into that company. So the world is changing, and technology and technologists are at the forefront of it. That is a message that I want to give on this Engineers Day function, and I wish you all the very best. Keep learning, keep hustling, and good things will come out. Thank you.
Thank you, sir. Now for the keynote speech, I invite Mr. Pradeep Kumar P, who is the Operations Director of Chandrayaan 3. Pradeep Kumar P is a highly accomplished professional with an extensive career at ISRO, serving as Deputy Head of the Atmospheric and Space Science Avionics and Checkout Division, and holding key roles in significant space missions. With a strong educational background, including an MTech in Applied Electronics and Instrumentation, BTech in Electronics and Communication Engineering, and a Diploma in Electronics Engineering, he has 35 years of experience in designing and developing data acquisition and control systems. Notably, he holds a patent for a solar radiometer instrument. Their major projects include contribution to Lunar mission, Mars Orbiter mission, and Chandrayaan 2 Orbiter mission, among others. Currently, he is involved in developing scientific payloads for various missions, showcasing their remarkable journey from a diploma holder to a prominent figure in the space industry. Sir, please.
Thank you. Good afternoon, all. Let me first make a correction. I am not Operations Director of Chandrayaan 3. I am only Operations Director of the Ramba LP payload on board Chandrayaan 3. This please note. So here, as you can see here, ISRO, Bharat reaching to moon and beyond. This title, I got help from our friends Siddharth and Ajit Chandran, Dr. Ajit Chandran. Actually, this was suggested by them. I think this is a very good title. And Ajit, I know from long, because we have been working together on some projects for ISRO long back. And since then I know him, and he is a very good friend of mine. In Siddharth, I recently met him. So let me first thank GTF for inviting me for this keynote address, and also the SCMS authorities and management for providing this facility. So as you can see here, this picture on the left bottom is a very common picture. Many of you have seen it. It's a very popular picture. Some rocket parts being carried in a bicycle. Those were the days when ISRO started. And now you can see on the right top is the Chandrayaan 3 lander majestically standing on the lunar surface. And this picture was taken by the rover which has rolled out of the Chandrayaan 3 lander, and it has taken the picture of the mother or lander. So ISRO has moved from this age to this lander age, and I will be covering in my talk the major milestones ISRO has covered, not all. And here, since the time is very less, what I have done is that I am not an oration speaker, so I have put a PPT in such a way that more stuff I have put in each and every slide, so that if any one of it is striking you and if it is igniting your mind, you can further pursue that and learn more about that. So I will not be covering all these stuff in this slide, but only some key points. So you can listen to me, but I would like you to see more in the slides. Pay more attention to the slides. So this, you all know that the Sputnik, it has created history, and with this, the space era started. And it also created a lot of thinking and discussions and curiosity across the globe. And that has come to India also. And that time, Dr. Vikram Sarabhi, an eminent scientist and an industrialist, he also thought that it is time India also should take up space program. And those were the times, just 1 decade after our independence, we cannot think of taking such a space program, because space program is always very, very expensive. Even now also the country is now financially in good status, but even after making success in Chandrayaan 3 and Mars missions and all, people still think and question why we are spending so much money on those things. So think of those days when we were just a country struggling with poverty and trying to develop and an underdeveloped nation. How can we invest huge money for space program? It was impossible to think at that point of time. But the visionary in Sarabhai is a great visionary. He thought we should be second to none in utilizing the advanced technologies and the space technology for the development of the common man. So he put forth this idea and he spoke to Nehru, the Prime Minister of India, at that point of time. He has very close connection to the Nehru family. So he was able to convince the government and start the Indian space program. Thus started our Indian space program. And Sarabhai industrialist in Ahmedabad, he came all the way down to south, some 2,000 kilometers and more, to Tumba, a small fishing hamlet in Trivandrum. Why he came all the way down to Tumba? There is a reason actually. That is, he was an industrialist and he was a scientist also. He was doing research in cosmic rays. And an atmospheric scientist, he would like to do research in equatorial plane actually. It is a very good place for studying the atmosphere. But equator is not crossing over Tumba or India. It is 8.3 degrees south of us. But there is another equator which is magnetic equator actually. The Earth is a magnet, it has got south and north pole. So there is a magnetic equator also for the Earth. So that magnetic equator is passing over Tumba. So that is a conducive place for conducting scientific experiments. So he selected Tumba, but when he came down to Tumba, it is a small fishing village and not much establishments are not there. Only one church is there and a flora villa, one tiled house with many rooms were there. And I think that was two noted buildings in those times there. And other things were small housings and dwellings for the fishermen community. So he came down, he had a discussion with the church authorities and he could convince them that he wanted to do research there. So they first gave a small place there. It was a thatched roof adjacent to the church. He started his Indian space program there actually. He brought some scientists and engineers from here, Ahmedabad, and started doing research, space research. So it was first engineers who were asked to build the rockets and systems, and scientists were asked to develop experimental systems, and thus ISRO started. So in 1962, this church started the ISRO space program. In 1964, it was the Equatorial Thirds was formed, the Tumba Equatorial Rocket Learning Station, and it was handed over to the UN for any nation to conduct experiment or launch rockets from there. So the first launch in 1962, I think, was 63. Now 21 November 1963 was launched from there, and the rocket came from America, and the computer and the surveillance helicopter came from Russia, and the payload, the scientific instrument came from France. So the first launch itself was an international collaboration, and it was actually given to the international community for doing research. And India always, as a global player, we would like to be a global player, and we always think of having collaboration with other countries. So this church is now converted into a museum in 1998. And after starting research there, he wanted to have more space, because if you want to construct a launching station, there should not be any human habitat nearby actually, because rocket launching requires a lot of safety net. So he could convince the church authorities to acquire 1,200 acres of land, almost some 5 to 6 kilometers stretch on the seashore between the railway line and the seashore. The area was to be acquired. So he was first able to convince the church authorities, later on the government, and that area was acquired, and now that is the Vikram Sarabhai Space Center now. So we have a launching station there. All the small rockets for atmospheric studies are launched from Tumba, and bigger rockets, you have our director, Rajaraja sir, sitting here. It is a sharp side, it's almost 50,000 acres of land is there. And the advantage is that if you want to launch a rocket from Earth, it is better to launch towards east actually. There are two things actually. If you are launching towards east, you can get the rotational advantage of the Earth. And if you have a sea also, if it is launched towards sea, it is good, because if anything happens to the rocket, it will not spoil the human habitat or any systems built by the humans. So C is one requirement and launching towards east is another requirement. These two requirements are met when you have a launching station in Sriharikota because we have Bay of Bengal there and we can launch towards east. So all the big rockets, all the satellite launching rockets are launched from Sriharikota. So space is an unforgiving space because there are a lot of things in space which we cannot think of. First and foremost is that vacuum is there. We don't have experience in vacuum. And second thing is high radiations are there. High energy neutrons, electrons and protons are always there. So you have to survive in that high energy atmosphere. And there is high temperature. It can go up to 150 degrees centigrade or minus 200 degrees centigrade. So this high temperature difference and you have to withstand. Then there is space debris because these debris are formed by human actions like launch vehicles create a lot of nuts and bolts in space. They will be going around the earth in several years and months. So there is magnetic field, there is radiation. So these are the hazards of the space actually. So if you want to build any space system, you have to take care of all these hazards. It is not like what we build on terrestrial place. So there is a difference actually. In terrestrial engineering or if whatever you want to make, you have a second chance. If you fail, there is a mistake. If you fail, you can correct it and go on. But in space, if you make a mistake, everybody will know you don't have a second chance to correct it. Okay. So that is a big problem actually. So it is expensive also. You cannot simply make mistake in space because it is very expensive. So in space, everything has to work in the first place itself. So that is one big challenge of doing things in space. So this is our comparison of our first SLV rocket and the Sputnik rocket which launched the Sputnik satellite actually. So in comparison, you can see that the Sputnik launch vehicle was 260 tons and the satellite Sputnik was 83.6 kg. Whereas our SLV, our first attempt, even though it was 23 years after that Sputnik, it was 17-ton rocket was launched at 35 kg Rocket satellite. So it is, in my opinion, it is 6.5 times better than this Sputnik because our payload capacity was 0.03% was the Sputnik, whereas ours was 0.2%. So even though we are coming late, we are doing it latest. So these are the satellite launch vehicles of India. SLV and SLV are not in operation now. PSLV and GSLV Mark II and GSLV Mark III, they are in operation. We have one more satellite launch vehicle recently developed, that is the SSLV. It is for launching 500 kg satellites into low Earth orbits. Just for a comparison of the payload capacity of these rockets, you can see here the PSLV, weight of the PSLV rocket is equivalent to 245 atmosphere cars. It can take the satellite weight almost 2 ambassador cars weight. And similarly, our GSLV 345 ambassador car is the weight of the rocket and 4 ambassador cars the payload capacity. Similarly, GSLV Mark III 525 ambassador cars and the payload capacity is 8 ambassador cars. So this is some exploded view of a rocket. So rockets are made in parts, various stages. The first stage and around the first stage we have strap-ons. Normally these strap-ons will be mostly liquid. For GSLV case it was liquid. And these strap-ons will be ignited first, then the center core. So center core will be mostly solid boosters. So once you ignite, you cannot control it. So here if you see the interesting thing here is that the payload capacity is 0.5% of the overall weight of the launch vehicle. So to carry as 0.5% of the weight, you have 99.5% of the weight in the rocket's weight actually. So in comparison, if you can see that if you are taking a truck for carrying 1 bag of cement, it is equivalent to that actually. So, but there is no other go. We have to carry this satellite into orbit. This much weight is required as a fuel and the body of the rocket. There are 3 types of rocket engines: solid, boosters, and liquid, and cryogenic engines in place now. The solid, as I told earlier, that once you ignite, you cannot control it, so it has to ascend fully. And liquid, you have the facility to restart the engine. So many times you can stop and start. And you need an oxidizer and a fuel actually. In that, the one advantage we are having is that all the engines, whatever engines you are having, that is petrol engine or scooter or car, we only fill fuel actually. We don't ask petrol pump when you go and fill the fuel, you don't ask for oxygen actually. But you really need oxygen to combustion oxygen is required and you need oxygen for the working of this engine actually. But we don't fill oxygen. But we have the advantage that oxygen is really available on the ground, so we can take the oxygen from the atmosphere and this engine can work. But that liberty or advantage is not when you are launching a rocket into space actually. You don't have oxygen there actually. Or it is, if it is there, it is in very tenuous nature. So you need to carry oxygen also along with your fuel. So that is why in rocket you have a fuel as well as oxygen. So in cryogenic engine, similar way, you have liquid oxygen and hydrogen. So hydrogen has to be stored minus 253 degrees centigrade and liquid oxygen minus 183 degrees centigrade. So this much low temperature, it is very difficult to handle actually. So you know that if you are carrying ice 0 degree temperature, it is very difficult to handle. Even ice also at 0 degree. So think of minus 183 degree and minus 253 degrees. It is very difficult to handle. And most of the material also cannot be used for handling this kind of temperatures. So we need special materials to handle this kind of this kind of fuel, and to hold this fuel as a fuel tank and engine, all parts of this cryogenic engine has to be special materials. We have launch pads in Sriharikota. We have two kinds of launch pads, launch pad 1 and 2. The first one, you can see here, there is a building behind that. That entire building, almost 12 story in height, can move on rails forward and backward. So if we coming to the launch pedestal where these rockets will be assembled vertically, the entire pedestal will go inside the building, will come and the pedestal will be inside of the building. Then we will be vertically stacking the rockets, and finally all the rockets parts are stacked vertically together, and after conducting all the tests, this building will go away. Then after that only launch will take place from the pedestal. Whereas in the second case, this building is stationary, this pedestal will be moving on the rails and it will go up into the building, and rockets will be assembled again vertically. After all the tests are over, this pedestal with the rocket standing vertically on it will be moving slowly to the launch pedestal and launch pad, and from there it will be lifting off. And what you see on the bottom is the control center, where the mission control and launch control will be happening for the launch. So this slide will depict how a rocket is taking a satellite into space actually. If you want to carry a satellite into space, for geosynchronous satellites, it is orbiting around 36,000 kilometers away from the Earth's surface. But the rocket is not carrying the satellite up to that actually. It will be carrying the rocket up to some 250 kilometers or 450 kilometers and injecting the satellite into an elliptical orbit, so that it will be some 255 by 22,000 kilometer elliptical orbit. Then there are small boosters in the satellite that will be fired to raise the orbit and finally reaching the final orbit. So this is how a rocket will be taking a satellite into space, and rockets also will be fired in stages, and each stage once it is suspended, it will be separated, and next stage will be fired, then it will be suspended and separated like that. And there will be a heat shield to protect the satellite when the rocket is going soaring up in the atmosphere. There will be a lot of heat generated because of the friction with the atmosphere. So to protect the satellite from this heat, there will be a heat shield around the satellite, and that heat shield will be separated after the rocket crosses the dense atmosphere. Then there is no more dense atmosphere to create that much frictional heat. Then it will be separated, and the satellite alone will be going at the top of the rocket. So these are some early satellites. We had Aryabhatta, right from Aryabhatta to the GSAT level. The mighty GSAT level is almost 6,000 kg weight, whereas Aryabhatta was some 360 kilograms. And these are different types of satellites we are having. We have communication satellite like GSAT and INSAT. We have Earth observation satellite, IRNS. Then we have scientific space satellite like MOM and Chandrayaan, and we have navigation satellite IRNS. Then this experimental satellite like SRE. Then small student satellites. Students like you have generated satellites, and ISRO has launched it. And these So these are the applications of the space. So based on the space assets, these many areas we are getting application support from the space, and there are many are there. I am not dwelling on that, but few points are what I would like to mention here is that earlier times during my childhood time, every year we used to hear about the cyclone in Andhra Pradesh or Visakhapatnam somewhere. Then thousands of people will be dying with every cyclone actually. Because we were not having any early warning system, or we were not knowing how much, when the cyclone will strike, what is the strength of the cyclone, what will be the speed of the wind. All those things were not known to us those days. But today, if a cyclone is happening, we will be getting early warning because of our satellite. Several days before itself we get the warning, and we will also know what is the speed of the cyclone, where it will be going to hit first on the ground. All these details we will get, and how much will be the effect of flood, all those things. So we can take enough precautions and shift the manpower or human or the establishments. We can do all kinds of measures to protect our human and their establishments. So that is one application of the satellite. Another thing is fishing, fishing community. So there is an app which gives support them that they can know where the school of fish is available. So they can go and fish there, they can put their net there actually. With this just one application, the entire fish catch every year in India has gone up by 40,000 crores actually. Just by one application. I am not talking about the revenue generated by the satellites and its airtime actually. So just one application is giving 40,000 crore per year additional amount, and our ISRO outlay for budget is much less than that. So whatever money we spend on ISRO, multiple fold we are getting it back. So these are some of the spin-off from the space technology, artificial links and special material for cloth, fire retardant material, and fuel cells where you can use remote places, you can have generate energy using fuel cells. So coming to the major milestones ISRO has gone through for the development of, as I told in the earlier slide, that right from the first on bicycles then to the moon. We had done several experiments. One of the experiments is this spacecraft recovery experiment, wherein along with the Cartosat 2, we took this module to space and it orbited Earth some 10 days. Then we deboosted it and brought it back to sea. So we recovered this, and this is available in the Space Museum in Trivandrum, only place is available. And when it is deboosted and coming to ground, it will be coming to the atmosphere with tremendous speed, and it will be cruising through the atmosphere, and due to again the friction, there will be lot of heat generated, and at the tip of this outer surface of this SRE was 2000 degrees centigrade. We all know that none of the metals available now will survive that temperature. Everything will melt, aluminum will melt, copper will melt, bronze will melt, everything will melt. So how do we make this? Because 2000 degrees centigrade is the temperature. And in fact this SRE was made out of aluminum. So how without melting we brought it back? The thing is, we developed a special tile, and these tiles were used to cover this aluminum SRE, and because of those tiles we were able to protect the aluminum structure inside without melting. And this came down, and we opened the parachutes, reduced the velocity, finally it flashed down on the sea, and there was a balloon which floated the SRE, and the Coast Guard could find it, and they recovered it. So another attempt was the Chandrayaan-1 mission. In Chandrayaan-1 mission, we were the first country to become successful in the first attempt. Soviet Union had 5 failures, and 6th attempt only they became successful in moon mission, and USA had 12 failures, and 13th attempt only they became successful to capture the moon. Because capturing the moon is a very tricky job. It is not that easy, but we were lucky, and we were, though we came very late, as I told earlier, we came latest, so we were successful in the first attempt itself. And another thing is the Chandrayaan-1 is the mission which found water on the moon actually. So I will be dwelling on that. Chandrayaan-1 had an orbiter and a moon impact probe. In the moon impact probe was having an instrument called CHASE. I was one of the team members. That instrument was a mass spectrometer. It has detected the direct evidence of water on the moon. And subsequently, American instrument on the orbiter MQ also found water on the moon. But unfortunately, their paper got published in the journal which rejected our paper. So, this CHASE is the instrument which found water on the moon. Because more than 100 missions were there before the CHASE which went to the moon. And astronauts were there. Neil Armstrong team has gone there. People have gone there and conducted experiment on moon. And they also tried to take water on moon. They brought back the lunar samples like rocks and all. And they did experiment to find out whether water is trapped inside the rocks or not. Still, they could not find water. So, under mission, they could not find water. But in our Chandrayaan mission, we could find water. So, similar way, just a major milestone was the Mars orbiter mission. In Mars orbiter mission also, we were the first country to become successful in the first attempt. How do we go to the Mars actually? So, here you can see the example how we went to the Mars actually. So, first it was launched and it went around the Earth for several orbits, almost 1 month. Then we fired and then it started the cruise towards the Mars. It was a 10-month journey towards Mars. And engine was off. So if you see the mileage, engine is off, it is traveling almost some 25 kilometers. Okay. So people were calculating that mileage is better than something like that, auto or something. I saw you different. Okay. So the thing is that engine is off, and finally when we wanted to fire the engine to capture the Mars, when it is going other side of the Mars, we will fire the engine and reduce the velocity. First we will turn the Mars orbiter mission and fire the engine in reverse direction so that it will reduce the velocity and it will go around the Mars. So it will be going other side of the Mars, so we don't have any visibility. The direct visibility is not there. We cannot control anything. We will not know what is happening also. Then again there was an eclipse as well as so sun is also not available. So the entire Mars orbiter mission has worked on the battery. So it has to be autonomous. It has to decide everything by itself because we cannot command it. So that 20 minutes of eclipse, what is going to happen, what is happening, we are not knowing. It has to do everything by itself. But another problem is here because the engine is off for almost 10 months and the temperature of the engine is minus 110 degree. So we all know that automobile manufacturers have perfected their engines. Lakhs of automobile engines have been produced in the country and the world. And even today, if you keep your scooter or two-wheeler on a night when it is cold outside, next day morning if you want to start, you may have to try several times. So a minus 110 degree engine was like 10 months, and if you want to start it, what is the guarantee that it will start? So we also had this problem. It was also there in paper that whether it will start or not. So what we did is 2 days before that, on 22nd of September 2014, we just few seconds we had a test fire. So if it is firing, we will know whether it is firing or not. If it is not firing, we have to take a plan B action. But luckily it was successful. The engine fired, main engine itself fired. So we were confident that main engine will fire. But we also had a plan B that if main engine is firing, there will be small engines every corner, that 2 engines will be there. So 8 small engines are there. We can fire the small engines and somehow we can capture the mass because ultimately we have to capture the mass. So this plan A and B was there. So 24th September 2014, our Mars orbiter mission went to the other side of the Mars and everything has to happen automatically as desired, as expected. Engine fired, main engine itself fired, and we could capture the Mars. And Prime Minister Narendra Modi also was there witnessing this event, and we could see the signals only after 20 minutes of silence because when the Mars orbiter mission came after the eclipse, then only we could get the signals from that. After that, we understood that it has captured the Mars. So it was a tremendous mission, and we got glory out of this mission also. There is one instrument in the Mars orbiter mission, MEMCA. I was also part of that team. And that instrument also measured a lot of Moon and Mars constituents, and some papers also have come out of that. And Mars orbiter mission, though it was supposed to work only for 1.5 years, we could operate it more than 9 years. and that was another success. Similarly, in Chandrayaan-2, sir has already mentioned what happened in Chandrayaan-2. It was an orbiter, lander, and a rover mission. Orbiter was very successful, landing and rover. Up to 5 kilometers, it came down. As expected, after that only it had some small problem, and it was a software problem. It was some hardware problem also, but had this software problem was not there, it would have been a success that time. Next one is Chandrayaan-3. In Chandrayaan-3 also, a similar lander and rover is there, but this time we already have the orbiter. Chandrayaan-2 orbiter is already there, it is still orbiting, it is still working also. So we don't have to have an orbiter this time, but in Chandrayaan-2, the lander and rover was taken to the lunar orbit by the orbit point. So we need something similar to that. So we added a propulsion system with the Chandrayaan-3 lander, and this propulsion system only took the Chandrayaan-3 lander from Earth orbit to the moon orbit. First it was 100 km circular orbit on moon, then it got separated, then the lander went into another orbit 30 km by 100 km. Then this lander was taking the pictures of the lunar surface. We already have the pictures taken by the Chandrayaan-2 orbiter, very high resolution pictures were there. So we already decided the landing point. It is a stretch of land, most conducive for landing, because on moon you have very high valleys and hillocks also. 2 km high hillocks are there and very deep valleys are also there. So you should find a place where a plane is available actually. And almost in South Pole area where we are going to land for the first time, there are a lot of craters actually. So to get a place without crater also was very difficult there. So we had selected some area, and that picture is already loaded in the lander. So lander is also having camera. So when it is coming down to 30 km, it is taking the picture of the landing area and it is comparing with the already loaded picture. So when it came down, when we started the final powered descent on 23rd August this year, 6:04 time it landed. So we were all watching that event. So it came down, deboosting started, so the rough braking started, it came down, and around some 1 kilometer it hovered and started taking the picture. Again it came down at 150 meters, again it hovered 50 seconds and took the picture and decided whether to land there or move away and land at a safer place. But it found that that place where it is there, it is a place conducive for landing, so it decided to land there itself. And as expected at 6:04, it has landed successfully, and it was a majestic soft landing. After the landing, we had a rover operations same night. So first rover ramp was rolled out, and through the ramp, rover has rolled out. And after the rover has rolled out, rover took the photograph of the lander. And there are 2 experiments in the rover also. And all the experiments, all the subsystems of the Chandrayaan-3 was working very successfully, and we had some this entire daytime moon was floating day long, so we could conduct all the experiments for the lunar day, and finally we went to sleep mode, because during lunar night temperatures can go down to minus 200 degree also. So we don't know whether it will survive after a one lunar night, and lunar night is equivalent to 14 Earth days. So after 14 Earth days in September 22, whether it will survive or not, will come to know. So when the lander and rover get the first streak of sunlight, we will know whether it will survive or not. So another mission which we recently had is the Aditya L1 mission to study the sun actually. So it is going towards the sun, it is going to be parked on an L1 point, Lagrangian point. That is a point where the gravitational pull of the earth and the sun will be neutralized. There won't be any gravitational pull. So if you put a satellite there, it will go along with the earth around the sun. So you don't need much energy to maneuver there. But if you put straight across in L1 point, if you want to have communication with the satellite, you will be always seeing the sun. So all the intense radiations from the sun will not allow you to have communication with the satellite. So what we are doing is, we are going to halo orbit, so that whenever we are communicating with the satellite, sun will not be directly in the line of sight. So next major mission is the Gaganyaan mission. Here it is easy to set a satellite into space. So that way, if you put a person also, it is easy to send. But the biggest task is that sending is safe and bringing him back safe. So bringing back, it's a technology involved thing. It is very risky thing actually. So one experiment which we conducted earlier in 2007, the SRE experiment, that was bringing back a module from orbit to the ground actually. So we have already demonstrated that technology, we have that technology. But now we have to human rated. So we have a human rated module now, 3 astronauts can sit in that, and several experiments were conducted. And one of the experiments is the pad-about test. In that, if anything happens to the, once the astronauts are going and sitting inside the crew module, if anything happens, anything can happen in space technology actually. If anything happens, the fire comes or if blast comes. So this astronaut has to be saved. For that, we have a pad-about system. In that, these rockets will be fired again. They will be removed from the main rocket and they can go up and land somewhere very safely. This is the pad-about test that also was conducted safely. Several tests are being conducted for this Conclave mission now. Parachute tests are being conducted. So almost all tests, whatever we conducted, they were all successful. So very soon we will be having this mission. And before the manned mission, we will be unmanned missions like this robot. And after that only we will be doing the manned mission. So one main thing is that we cannot take a second chance. So we have to test everything thoroughly. So whatever we build, all the components, all the materials used in space, we will be screening and we will be testing also. And if we want to use a nut, we should know the entire life cycle of that nut, which material was used to test, make that nut, which manufacturer has done it, which batch number it is, and what test it has carried out. And all these details should be available, then only we can use any material or any device or anything for a space mission. And similar way, whatever we are going to use, we have to test it thoroughly. So all the components, when we are testing, there are some tests which is destructive test, there are some tests which is non-destructive test. So if you do a destructive test, then we cannot use that device. Then how do we use a device without conducting destructive test? So what we do is actually we take a lot of 100 from the same lot and we will be doing test on all the 100 which is non-destructive, and destructive test will be doing on some sample 5 or 10. If all the samples survive or some number of percentage of samples are surviving, then we assume that the remaining 90 is good. But there is a chance that one of the 90 or many of the 90 can be still bad. So that is always the risk associated with the space technology. So we have to use some systems in space technology without any testing actually. So if by our bad luck, if that becomes critical, then it will be a failure actually. Even a small failure will be a big failure in space. So that is the criticality of space technology. You cannot ensure 100% success in space technology, but we will strive to ensure that whatever we can do on ground, we will do that. We will not leave anything to chance. We will do whatever we can do. Remaining, we have to leave to the chance only. That is the risk associated with this space technology. So, and so far, ISRO has launched satellites weighing. Total weight of the satellite can be 65,000 kg. So that much our space asset is there with us. So this slide is a slide which always I like. With every countdown, this count will increase. Whatever count you see on the bottom will be increased. So far we have 150 missions and we have launched 431 foreign satellites. So you can think of the revenue we have generated out of that. So for students also, ISRO is doing several things, and students are encouraged to build student satellites. If students can build a satellite, ISRO is ready to launch it, and we will also be helping the students to build the satellite. So I invite you people to take up some challenging job like this, make your own SCMS satellite, and come to approach ISRO. I generated out of curiosity, because in recent times in newspaper, these two were discussed. One is many of the NRIs in major countries, European countries and America would like to come back to India after their retirement. almost 80% people want to come back to India. And the bottom one is the tweet that CETs are taking us to moon and IITs. What I want to like to say is that you are the people, you can take our India forward, you are the torch bearers tomorrow. So you don't have to look abroad, opportunities are here immense. Just use your brain, keep a focus on your goal, work for that, definitely you will achieve success and we can take your country forward.
Thank you, sir. Does anyone have any questions to ask?
Can I ask you a question?
Yes.
Pradeep, that was a very informative talk. You could put everything in a nutshell. Just one question. The chairman ISRO had made a statement that Chandrayaan 2 was planned for success and Chandrayaan 3 was planned for failure. How can you explain that a little bit?
Actually, Chandrayaan 2, normally, as I told, we will conduct all the tests possible, whatever feasible we will do. So Chandrayaan 2 also, we have conducted all the tests, whatever was feasible at that point of time. But after that Chandrayaan 2 failure, we learned a lot of lessons actually. Because of the lessons we learned, in Chandrayaan 3, we actually did lot of tests and we also did lot of changes in Chandrayaan 3, removing one engine and other things and adding some more sensors. And what we did is that we did not give any chance for failure in Chandrayaan 3 because we cannot afford to have another failure. That is why we did all the possible things to avoid a failure. So that is why it's made that statement.
Fault tolerant systems.
Yes, we had a lot of redundant systems, but luckily and the main system itself, but none of the redundant system was called for. Thank you.
Pradeep, sir, one more question.
Yeah.
In the Chandrayaan 3 mission,
Yes.
one instrument on board the lander is still working now, even during lunar night.
Chandrayaan 3 lander is put into sleep. Lander as well as rover both are put into sleep. So that sleep and wake up circuitry will be still working.
That's one circuit. But one instrument, one payload is working, I don't remember correctly.
One payload.
One payload is working.
Yeah.
It's working, it will work.
It's working. That doesn't require that much of power, no?
You have to decide, that is the place belongs to us.
There is a shape payload on the propulsion module also.
Exactly.
Can I ask one question?
Yeah.
Are there any alternate energy sources that you are trying to find out? Basically because you say 90% of this thing is for 90% of your vehicle is used as energy source. So is there any alternate energy source that you are looking at for launch of these vehicles?
Actually, one thing is that if you can avoid carrying oxygen, you can save half the weight actually. So there is one technology, air breathing technology. So we have already demonstrated successfully. So in future, if we are able to make an engine without carrying oxygen and take the oxygen from the atmosphere, and even though it is very rare, then we can increase the payload mass.
The one more thing that
Yeah.
I wanted to ask was, are there any standards that you follow? Because your technology is unique, the technology by NASA is unique, by Russia it is unique. So, are there any international standards that you follow with respect to this manufacture of these equipments, their reliability and all those things?
Actually, ISRO has got its own standard. Standard for hardware is there, standard for software is there. But there are other NASA and ESA standards are also there. But we will see all these things and make a standard which is more suitable for our purpose. So that is why ISRO is having its own standard actually. So and we have to meet that standard. If you are developing a software, you have to go through all the life cycle of the software development and you have to follow all those standards. Similar way for the hardware also. And we have to do all the test and evaluation based on those norms.
So what about the battery? Is it solar powered or rechargeable or
Like our
You are talking about the lander battery.
yeah, inside that.
It's a rechargeable battery and charged using solar power actually.
Solar power.
Yeah. So we have operated it till almost that the charging has come down to some 3 ampere and dot. So whatever maximum we could operate, we operated. Then we put it on the sleep mode.
How do you ensure solar power intensity measuring or anything?
Yeah. First thing is, as far as rover is concerned, before we switched off the rover, we have oriented the rover in such a way that when sun comes, rover solar panel will be getting the maximum sunlight. So we oriented that way and put it into sleep. Lander anyway, though we did a pop-up experiment, it is in one place. So that place also is having solar panel all around of the lander. So when the sunlight comes, it will be generating solar power and it will be charging the batteries. If it survives, we can still operate for another 14 days of daytime.
So all solar powered only, not like our primary battery in the mobile, like high ampere.
No, all are rechargeable batteries. Yeah.
And Pradeep sir, there's one. I want to ask you one question. There are IEEE standards for terrestrial instrumentation, electronics, etc., which is independent of the manufacturer and all that. HP has a device. It has to connect with a Wipro device or a GE device. There are standards.
Yes.
Do we foresee any standards in space in the future? Maybe reinventing the wheel maybe can be avoided if that is done.
Every walk of life, it is getting standardized.
Yeah.
So in future in space also there will be standardization actually.
Yeah, it should come up in the future.
Yes.
Then another question, you talked about the sun's intense rays affecting communication. No?
Yes.
Basically, it's microwave communication, microwaves.
Yeah, sun is having a wide spectrum of radio waves actually. Solar energy.
So that will affect the microwave spectrum.
It will affect the microwave also.
Out of curiosity.
Actually, we use sun to actually calibrate radars actually.
Okay. And that 65,000 kg of mass which we sent.
Yes.
How much is still existing there?
It's a difficult question to answer right now. Actually, many are functional. Some have suspended their life. Okay. So it will be a dead mass.
Just out of curiosity, yes.
Yeah, major satellites before it is going to die, the life of a satellite is depending upon the fuel available. So before the fuel is fully utilized, we will take the satellite to a parking orbit, so that the orbit it was already working can be used for another functional satellite which is going to come.
Just one more last question.
Yeah.
I hope I'm not disturbing others. You discussed about the launch pad 1 and launch pad 2, where the movement is reversed in launch pad 2. Is there any advantage, logistical advantage or technical advantage in that?
I think sir is the right person to answer that question.
Sir?
It is only integrate at launch pad and launch. That's one concept where we can have, if we have any issues with some launch vehicle, they develop in the launch vehicle. That's one concept. Another concept is assemble in the an integration building and move it on rise to the launch pad. This is the modern concept. So this all evolved because of the timelines and this one. Always vehicle assembled at the assembly building and then move it to a launch pad is the best, because occupation at launch pad can be minimized. So I can have a number of launches. Actually, we have 3 integration building with 1 launch pad. We can simultaneously build and launch those. That ability exists. That's why we don't want to go to 30 launches per year and doesn't go on. So that is a benefit. And it depends upon the technology and know-how. I don't know. It all comes evolution. Now, this concept also, now we have built a rail. It's also changed into integrate, transfer and launch. Both are same.
Thank you so much.
Hello? Hello, one question, sir. 2 questions I have. See, this position or velocity is always, you say, respect to something. Now, when you monitor the position of the satellite, can you physically monitor it on a simulated model when the satellite is traveling on its way to the moon? How do you monitor it?
Yeah, actually
You
there are
say
many.
that it's the question is here, we get it from the media.
Yeah, actually, whatever communication system we are using to communicate with the satellite, we use the same communication system to also know the position of the satellite. It's just like a radar at land.
So it will show you the question,
Exact-
something assimilated model.
Yeah,
It will
exact
show-
position of the satellite with respect to Earth we can.
It will show the position. Okay, then one more question. Now, when you control the satellite from here, so it's at a distance. So
Yes.
what is the time delay between your command to the satellite and the way the time it acts?
Yeah, depends upon the distance actually. For moon it will be few seconds, 1 or 2 seconds. For Mars mission it can be minutes also, take 12 minutes and more.
So you always have to give a command anticipating that delay and maybe 2 seconds in advance, something like that?
Yeah, actually there are something called time tag commands. So we know some event has to take place at some point of time. So much before that, 1 hour before or several hours before that, we will load those commands, and there is a time lag with that. So when that time happens, automatically those commands will be executed. And some of the things is autonomous also. Satellite has to take a decision by itself because you will be knowing after 12 minutes, as the case of Mars mission. Then when you take some action, you may take some few minutes to take action, then another 12 minutes to reach that action to the satellite. Then altogether it may take half an hour. So that much liberty you may not get. So things can go wrong. So certain cases satellite has to take an autonomous decision on board itself.
So especially the question is when it is landing, that is more critical, no?
Yes.
So you won't have time to give a command. So does it take its own decision?
Yes,
It's
landing totally autonomous. Itself has decided the way. But there are some procedures. Procedures were preloaded before the landing started.
Thank you.
That is actually distance by speed of light. The time taken.
Pardon me?
Distance by speed of light. No?
Yes, yes.
That's all.
Yeah, 3 lakh kilometers per second. This speed of light, the radio waves also goes.
Thank you, sir.
Any more questions? Thank you so much for listening. Thank you.
Thank you so much, sir. It was very informative. Let us now listen to what Padma Shri Sridhar Vembu has got to share with us on this auspicious occasion. Sridhar Vembu is an Indian entrepreneur, founder and CEO of Zoho Corporation, was renowned software and CRM company. He is the President General of Bharat Foundation. He was awarded India's 4th highest civilian award, the Padma Shri, in 2021. In 1989, he did his bachelor's in electrical engineering from the Indian Institute of Technology, Madras. Later, he studied MS and PhD degrees from Princeton University in New Jersey.
On behalf of Bharat Tech Foundation, I want to wish all of you a very happy, productive, inventive Engineers Day. Engineering really is nation building. We don't just build products, we don't just build technologies, we literally are building the nation. Everything from our infrastructure, from trains, to the products in our households, everything rely on ultimately built by some engineer. And of course, our Chandrayaan mission, the success of landing that probe on the moon, gave us all in India such a big boost in our own technological capabilities. It gives us the crucial self-confidence we really need in our nation so that we can go and invent products and solutions that are suitable for our market, our conditions. And I want all of us engineers to not just think of products that we use every day, those are vital, but also look at the process, the production process that's involved in making those products. The machines that make the machines will know, that's what I call it. The machines that make the products will know. Those production technologies are as vital as the finished products themselves. It is the control of those production technologies that give us really vital prosperity as a nation. So on behalf of Engineers Day, I on behalf of Bharati Foundation, I want all of us to resolve ourselves to be really outstanding engineers that not only are capable of building finished products, but also the machines that make the machines, the technology behind the products. And the crucial technology there is mechatronics, that is the combination of mechanical engineering, electronics, and software. But increasingly all of these machines are software driven. And we want to be able to compete well in this. We have an inherent advantage in software in India. We have to apply that software know-how to manufacturing, to all of the automation of them. That's really what Industry 4.0 is about. And we want to make that put a clear signature on this. So that is why Farman is there. And once again, I wish you all the very best for Engineers Day. Thank you.
Now, I call upon Honorable Chief Guest Sri A. Rajarajan to hand over prizes for Ideathon and Seminar.
Here is the awaited result of Ideathon and Seminar. Ideathon. The second prize goes to Anirudh V. Kumar and P. A big hand of applause. The first prize goes to Sanderi Bhatt and team. College. And for the seminar, the second prize goes to Aditya Hari and team. Now, put your hands together for the first prize winner, Gopi Unni and team from SMS College of Engineering and Technology. Thank you, sir. Now, I invite Professor Dr. Radha P. Kevindu for presenting the mementos for the speakers as a token of gratitude.
Please note that these mementos is the aesthetic work of Urja, which is an organization that empower differently abled people.
At SCMS, we support many NGOs, and Urja is one such NGO who provides a lot of support to differently abled people. We hire from them We have 5 staff members from Urja. They are, 3 of them are working in this campus, 2 others in another campus. And the memento that you're seeing are made by their, under their logo, Tashkent. If you just Google, you can understand. So young boys and girls, if you feel like gifting somebody, a close friend, something, do go to their website, and of course it's a bit more expensive because it's a hard work, it takes more time for them. Many of them are immobile, they are literally, some of them can't even sit upright. So, but this is an initiative that has been going on since 5 years, 6 years.
Now, I invite Mr. Pradeep Kumar for receiving the memento. Next, I call upon Mr. Surendra Kumar for receiving the memento. Finally, I invite Mr. Sunil Hardas for receiving the memento. Thank you, ma'am. Now, I invite Mr. Surendra Kumar to speak on BTF The Way Forward. Surendra Kumar is a highly experienced professional with nearly 3 decades of expertise in strategic planning, project management, and general management. He excels in value engineering, procurement, and cost-effective project completion. Currently, he is the founder of Solution Hub, driving innovation and entrepreneurship. Previously, he held the position of CEO at Vision Engineering and Contracting and various senior management roles at Schneider Electric. Surendra is known for the relationship building, business development, and strategic partnership skills. He is adept at managing teams, motivating individuals, and handling change effectively. He is also passionate about knowledge sharing through training and hosting podcasts. Sir, please.
Hello. Guys, are you ready? Yeah. Because everyone should be charged up from morning, I think 10 a.m. We are into space exploration. We have gone through Industry 4.0. So, let me see, are you charged up? Yes. Let's. More. Are you charged up? Yes. Okay. So now, my job is to show the way forward of BTF Kerala chapter. Respected engineers, my dear students, ladies and gentlemen, as we gather to discuss the future of Biotech Foundation Kerala chapter, I am honored to represent an organization that unites global engineers in their pursuit of excellence. This chapter holds a special place in our hearts because of the significant population of engineers from Kerala in the global scenario, or those people who have made a mark on the world stage. Today, I would like to shed light on the unique role that BTF and BTF Kerala chapter can play in this ever-evolving engineering landscape. Before we delve into why, let's take a brief journey through the history of the management paradigms in the industrial world. See, when you have to look forward I think, when you have a car, you have a mirror in front of you, and you have two rear mirrors to look at the back. So it's very important for us to understand what happened in the past so that we can appreciate what is going to be the future. Otherwise, it's all, everything is happening simultaneously. So back in the 1940s, during the height of industrial revolution, the norm for anybody to work was by the term called management by instructions. There was a superior or the manager, and the manager simply gives you instructions and you obey. You don't use your brain. That was the 1940s. Then we moved on to, in the 1960s, there was a change. The Harvard schools came up, business schools came up, and then the management changed to management by objectives. So people were focused on objectives. They were saying that yes, using brain and objectives being set, and they were following objectives. Late until the 1990s, that was the norm. But what happened in 1990s? Yes, we had the internet revolution, and technical giants like Google came up. And then we have a new management term which came management by values. People started really valuing your ethical values, and so people changed from management from instructions, from management by objectives to management by value. But today, where are we? We are talking of Industry 4.0, and what is going to come, or what is already in, is management by technology, MBT. So we are already in the era where the management happens by technology. And today, we are happy to say that the Pilot Tech Foundation is born and during this digital era, and our mission is clear: to engage with participating engineers and guide them in the art of unlearning, relearning, and reskilling. So our mission is very clear. As our earlier speakers, Sir also explained that the most important thing is to unlearn, relearn, and reskill yourself. So this doesn't apply to practicing engineers. When I look at the students, you will be graduating today. But in the next few years or a decade to come, what you have learned, I don't want to use the word, it will be obsolete, but you will have to be constantly on your toes to learn. So be prepared for this, and BTF is going to guide you in this, and this is what the plan for BTF Kerala is there. We are planning for an Academia Industry Connect. So our Academia Industry Connect program tries to bridge the existing gap between educational institutions and the industry. We propose to facilitate upskilling of technical faculty in the engineering colleges in Kerala with an active collaboration of premier industry bodies like the CII, so that they are well exposed and responsive to the current and future technology needs of the industry. The same applies to students. We will be having seminars, we will be conducting workshops, and we will be providing, or we will be assisting to identify companies that can give you internship. Today I heard one of our speakers saying that they're open to students working during your study period. So this is what BTF is also really planning to do. Furthermore, our consultancy services initiative, this is very important. We tap into the wealth of expertise among practicing engineers. By harnessing their collective knowledge and international best practices, we aim to benefit both the country and the individuals involved. And the most important thing, what currently we are doing, currently BTF Kerala is already doing, we have got a projects division. So our commitment to impactful projects is unwavering. We have established a working group that assesses various problem statements, and once they meet our rigorous standards, dedicated project team relentlessly works to find practical solutions with technical and financial impact. Also, which is benefiting the society. Circular economy projects are of particular focus. And the most important is, in addition, we are dedicated to supporting startups. Plans are underway to establish Center of Excellence and Technology-Based Incubators, TBIs, in specialized fields such as space technology and drones, which can significantly impact sectors like agriculture also. Last not the least, I think this is very important. We are launching a membership drive that aims to involve engineers from academia, private sector, public sector, and the the engineers who have returned from their international experience from the Middle East, the Europe or USA. In conclusion, the BGF Kerala chapter is not just another organization for engineers. We are a force for change and progress, a beacon guiding engineers towards success in the digital era. Through our programs, initiatives, and the collective wisdom of our engineering community, we aim to empower engineers to thrive in the dynamic landscape. Together, we will unlearn, relearn, reskill, and transform Bharat by developing 21st century skills such as critical thinking, problem solving, digital literacy, and communication. Thank you very much.
Thank you, sir. And finally, for the vote of thanks, I invite Mr. Sunil Haridas. Sunil Haridas is a senior technology leader with more than 30 years of global expertise in application and product development. He is an ex-Infosys, ex-IBM with account and delivery management experience in US, Australia, Thailand, and Singapore. Sunil Haridas is currently the founder and CEO of Pratna Implicit, an AI ML IoT product company based in Trivandrum. He is a member of C2 Startup Panel, FICCI Startups, and TIE Bangalore. He is also the Vice President of Kerala Startup Network, Mentor in Deep Tech Council, NASCAP, and Airtel Innovation Mission. Sunil is a coordinator of National Working Group on AI Technology Standardization, TechDot, Ministry of Communication, Government of India. He is an engineer, MPA, and an alumnus of IEM Calcutta. Sir, please.
Good evening, friends, esteemed engineers, and all panel speakers. So my responsibility today is to say the vote of thanks, and I think all of you had a very hectic day, and there is a lot of things to imbibe and digest, because we had starting with a lot of discussions and talks on space exploration, on Industry 4.0, on future skills, or future of work, and of course on BTF, how we as an organization can play a vital role in bridging the gap between the industry and academia to provide the right level of support, not just for the faculty, but also for the students and practicing engineers. So we have had a extensive level of discussions on all these things. So my job is to actually conclude by saying the vote of thanks. So first of all, I would like to thank our chief guest, Sri A. Rajarajan, for his extremely passionate and to the point guidance, as well as the speech, where he has given the right level of advice to our students and to even practicing engineers. So thank you so much, sir. Next, I would like to thank the SEMS management, especially Dr. Radha Devanur, for her extensive support and which goes beyond the expectations, I would say, in terms of helping us and making sure that everything works as per plan and making sure that we get the right outcome. So thank you so much, ma'am. Again, I would like to thank other speakers like Dr. Srinivas, then of course Dr. Anida Pillai, Principal SCMS College of Engineering, then Mr. Karthik Parsuram, who gave the guest of honor speech in the afternoon, then all panelists. I would specifically would like to thank Prateek Sutar, Pradeep Ramachandran, then Sina Simon, and Hari Krishnan. Of course, with moderator Ajit, and before I forget, definitely we had a wonderful speech from Mr. Pradeep Kumar, and which covered a lot of ground in terms of the various aspects of our space program. So thank you so much, Mr. Pradeep. And it would be not sufficient on my part if I don't thank two pillars of our support who have been supporting us from the day we started engaging with SCMS. So I would really like to thank Professor Vinda and Varun, who have been very supportive. And we couldn't do without you, so really thankful to you. And finally, I would like to take this occasion to be very thankful to such a wonderful and responsive audience, including all would-be engineers and would-be managers who have been very helpful, very supportive. Especially I would like to thank the two MCs. You have been great. Thank you so much. And I would like to thank the judges of the two panels, one for our Ideathon, other for the seminar or the web presentation. So thank you, both of you. And finally, I would thank all of you on this dais and in front of the dais, for having been such a wonderful audience. So thank you so much.
Thank you, sir. Thus, we come to the end of this dynamic session. I take this opportunity to thank the delegates, the participants, and the students on behalf of the entire BTF and SCMS family. This is Hasana Samira,
Anna Maria,
signing off. The tea is served outside. All are requested to